record. Okay, before I start, are there any questions about what we've talked about so far, or what, especially as far as getting started with NetBeans and especially GitLab? I noticed that about half a dozen of you or so have already kind of more or less reached the finish line on that. So of those who haven't, have you just not gotten to it, or have you encountered roadblocks or difficulties?
Hey, good morning, sir. I'm having issues with some reason the password is not connecting between GitLab and my MPS account.
Oh, really? So, I mean, it should be exactly the same as your NPS login.
Yeah, but then when I go to NetBeans to enter it in, the password's too long.
As far as I know, NetBeans doesn't really have I mean, a limit on that. Are you able to log into your to GitLab with a web browser?
Yes.
Okay, so um,
I'm going to try it again this morning. I just kind of gave up last night on it.
yeah. That's a new one on me. I've never encountered an issue with the length of the password before in NetBeans. So it might be something else. What you might want to do is you in your if you have a saved login to GitLab in your web browser, if you go find that password, just sort of copy it and then paste it into the place in NetBeans, that ought to work.
Okay, I'll try
Because
it now.
if it's letting you log into the GitLab, that means that it's accepting that password.
Okay.
Okay.
Okay, thank you.
Okay. Any other thing? Yeah, the GitLab is the trickiest thing. I mean, it's you all seem to have at least a little bit of experience with NetBeans. You know, maybe not to the extent that we'll be working with here, but that NetBeans is fairly straightforward in that regard. Git and GitLab is it can be a little tricky. It can sometimes be infuriating, but the benefits of it completely outweigh any of the problems. And actually, all the problems are actually good problems, because they typically will keep you from doing something that you shouldn't be doing.
Sure. So if we got an email that says we've been granted reporter access, does that mean everything's set up?
Yes, yes. If you got an email from me saying that you've been granted reporter access, what that gives you is that gives you access to my my GitLab, the one that I started in the video. And in fact, I'll be kind of showing that. What that will let you do is you'll be able to clone or download directly to NetBeans from my repository. So any code that I develop, and I'm hoping to do some this class and every class if possible. Any code that I write, once I commit it and push it to my GitLab, you'll be able to pull it down from there. So, because I mean, here's the thing: is that what I try to do is I try to actually do as much sort of live coding as possible, which is sort of write the code in front of you. Typically, you know, if you're trying to kind of type along with me, that's probably going to lead to a lot of frustration. But since you'll be able to get everything that I do, and in addition to it, you'll be able to watch the video, and you'll also be able to literally pull down the code that I've written and take a look at it there. So you don't have to worry so much about trying to follow along with your typing, but just kind of, you know, watch it, and then afterwards just you can kind of see what was done, and you can also follow along with the video as well, because in real time it will probably go a little bit too fast for anybody to keep up. Okay, so
I have one more question, Arnie.
sure, please.
Is it kind of like OneNote where you can, now that we have it linked, when we work in NetBeans and save it, is it saving it in GitLab as well?
No, it's not. It's not. uh, it's like that a little bit, but in fact, your local copy of the repository and the one on GitLab are actually two completely separate entities. So anything you do locally does not get automatically saved to GitLab. You have to explicitly push it. That's
Okay.
actually a good thing because what that gives you the opportunity to do is you can do many local commits as you want, and then once it's in a state where you feel it's more or less working, or at the end of a day or a session or something, then you push it up to GitLab. So you have to explicitly say to GitLab, okay, here it is.
And then it's gonna override that file, overwrite that file.
Nothing ever gets overwritten. It will look like it's overwritten, but GitLab saves every Git and GitLab will save every commit that you do. So if you ever do a commit and it's an oopsie, you can go back to something previous. I mean, that's one of the huge benefits of using a version control system like Git. So once if I do a commit, and let's say I do some more coding and I do another commit, and I go, oh crap, that really sucked. I liked it before. Well, I don't lose anything. I don't lose any commits. Okay, does that, hopefully that'll become a little clearer as we go along. Okay, anything else? These are all great questions. Okay, so where we go? Okay, so on the docket for today. Okay, we're getting introduced to objects. Now, if you've been through the Chris Darkin's class, then you've probably had a little introduction to JavaScript objects. Is that a correct assessment? Okay, yeah. In a way, that's a little unfortunate because the way JavaScript does objects is kind of not so great in my view. Okay, so Java is more of a pure object-oriented language. It's only 99.4% pure, as I mentioned, but it is mostly object-oriented. So what are these object things? And so the way JavaScript does it is a little bit unfortunate because it's a consequence of the fact that they don't have strong typing. So what Java introduces extra layers of complexity to this, and those extra layers of complexity are in fact good things, but they're more complex. Okay, so what is objects? What are objects about? Again, we're going to be having objects coming out of our ear this quarter, but it's about abstraction, interface. Okay, what is an interface? We'll kind of address that actually. The use of interface here is going to have, as we proceed in the course, is going to have some double meanings, but services is kind of a powerful concept. Hidden implementation or encapsulation, that's a key aspect of object-oriented programming, and inheritance and this is a idea. That's something that was kind of, it's important, but not as important as it once was, but it's important enough to kind of talk about. Okay, so takeaways from today. In the readings, you encountered Alan Kay's 5 characteristics of objects and Grady Booch's 3 characteristics of objects. Again, these are 2 pioneers in object-oriented design, so I think it's useful to understand what it is they were talking about. Because when they were doing this, the whole object-oriented concept was fairly new. Now it's fairly well old or mature, as the case may be. When it comes to taking a look at what an object is going to be doing, this thing called UML is is a valuable way of just kind of looking without having to pour through code. It's a way of seeing what an object or a class is going to be designed and what it's going to do and what kind of data it's going to contain. We'll see an example of that. So identifying the type of a Java object. This type thing is something I'm going to be haranguing on a lot. It may be a little bit new to you if you've only programmed in loosely typed languages. JavaScript and Python are loosely typed in the sense that the concept of type is just kind of vague. Java is a strongly typed language. The concept of type is absolutely OCD, so we'll see about that. Be able to identify what a class's inheritance hierarchy is about, again, usually through an UML diagram, and also how Java does it. And identify which methods are allowed in an object of a different type. And that can get a little bit tricky once we introduce inheritance. So we'll talk about that. Okay, so here, just as a review, these are in the book. So K's characteristics was, the idea was everything is an object. And this was revolutionary at the time, because at the time, the predominant way of programming was procedural. So what you did was you basically started at the top of the page and you went to the bottom of the page. The idea of everything being an object and these objects sending messages to each other, that's a very nonlinear way of programs operating. And again, at the time it was revolutionary, and over time it has turned out to be a very valuable one. Another thing is the idea of every object having its own memory, and they say made up of over other objects. So in a 100% pure object-oriented language, the only one there was one called Smalltalk, which is part of ancient history. Currently, languages such as Ruby are more purely objects-oriented in the sense that everything is an object. Java is kind of mixed because it has both objects and primitives. Every object having a type, again, that's a very important concept, and one that can drive people who are, if you're used to a loosely typed language like Python or JavaScript, this can sometimes drive you a little crazy, but it's a good kind of crazy. Okay, Grady Booch's was a little simpler, but in a way encapsulates the whole idea. State, which is what corresponds roughly to the idea that every object has its own memory, its own state. Behavior roughly corresponds to interface or methods, and identity, meaning every object has a unique identity, which is distinct from every other object, both of the same type and of other types. Okay, so this type idea is a very important one. And from an object-oriented perspective, type in Java's language, type and class are more or less synonymous. In other words, as we'll see, we will define classes, and every class is going to specify what type of objects there are. In Java, everything is in a class. That is, in Java, there's no such thing as a function just kind of sitting out somewhere. There's no such thing as a global variable just kind of sitting out somewhere. Everything is going to be in a class. So in creating a program, what you do is you define abstract data types, which is a fancy word for saying a class. And you use both there are two kinds of classes, user-created classes and built-in classes. So the built-in classes consists of this huge library which Java provides, which provides much of the functionality that you want. But as a user, when you write a program, you write your own classes. And so you use those classes by creating the objects or instantiation. So you create an object of a particular class, and then you have the object send messages. So just in the Hello World program, there was a little example of that. So in the Hello World was defined as a class because everything in Java has to be in a class. It used a built-in Java object called system.out. System.out is an object of type print stream, and a print stream object is something that just writes stuff to the console. Actually, it just kind of prints something out somewhere. You can actually redirect it to a file and do a bunch of other things. But the important thing here is that system.out is an object of type print stream. And the print stream object can receive a message called println, println. And when you send the message println to the object called system.out and give it a string, then what it does is it prints that string to your console. Okay, so you've already been using object-oriented programming, just like Mrs. Malaprop, who had been speaking prose all her life and not realized it. Okay, so you've already been using a built-in Java object. Now, you say, well, where did that object come from? Well, that object that's instantiated kind of automatically. Most of the time, you have to explicitly instantiate an object. Okay, so this UML stands for Unified Modeling Language. There were three people, actually Grady Booch was one of them, and they had three different ways of kind of describing object-oriented programming. And at one point they got together and decided to kind of unify things. And UML is actually a whole language in itself. It's actually very complex. The one part that's going to be very useful for us though are these things called class diagrams. And so here's an example of a class diagram. What this does is this describes a class's instance variables or its state and its interface, that is its methods. Okay, so there are three parts. Okay, one is the name. So this is the name. So the name of this class we're going to call it light. Then in the next section, it just describes the instance variables or the state. And you'll notice that it also has modifiers. So in this case, the state of this light is actually not, these aren't objects, these are actually primitives, but they should be, roughly understood. In other words, it has one state variable called on, which is of type Boolean. So a Boolean is a type. It's either true or false. It has another state variable called level, which is an int. And an int is an integer. So that's, again, these are two primitive types. That's the reason why Java is not a 100% pure object-oriented language, is because there are 8 primitive types that are not objects. So these are not objects, but if we instantiate a light, it will be an object. So, and here's where it gets a little bit tricky coming from JavaScript. So coming from JavaScript, it's probably most useful if you take everything that you learned about objects in JavaScript and put it aside somewhere, at least when we're doing Java. Because JavaScript uses this concept of templates, which, and that was their Band-Aid, so they didn't have to deal with types. Okay, Java is strongly typed, which means that if I have a light object, then what I can do is I can send it any one of these messages. And you'll notice that these messages or methods you notice they have little parentheses, which indicates that they're methods. They also have stuff before them. And what is that about? That is the return. So every method in Java has to specify what it returns. Again, this is different than what you may be used to. You may be used to just sort of defining a function, and at the very end, you either return something or you don't. And if you don't return something, then it doesn't. And if you do, then it does. In Java, you have to explicitly say that. So here's the thing. This word void, this keyword void, that says that when you send this message, turn on, nothing gets returned. So you shouldn't expect anything. In fact, all of these messages here do not return anything, but these do. Okay, now notice that is on. If I send it the message is on, I expect to get a Boolean in return. And what is that Boolean? That Boolean will tell me, well, and again, these are named so that they should be fairly compelling. In other words, if I send a message is on and I get a Boolean back, then if this has been correctly implemented, it will be true if this light happens to be on, which is this Boolean is true, and it'll be false if it's off, meaning that this Boolean is false. And likewise, if I say get level, it will return an int that will be the value of this level. Okay? So how do we use this? Well, let's look at some code here. So here's, and this is where there's a bit of more overhead than you may be used to in JavaScript. Okay, so first I need to declare what type of variable my object is going to be. So here I have declared my light to be an object of type light. That's what that statement does. But at this point, actually, the value of my light is something called null. In fact, it isn't anything yet. At this point, it's null. It's nothing. I've simply said, this object is going to be of this type. Now I've instantiated it. Now it is not null at this point. Now it's not null. And what is it? It's a new light. And now I can send it a message. And if I send it the message, turn on, then if it's designed well, it will, what the turn on, where is it here? The turn on method will change the value of on to true. However, look at this. If I try to send a message like this, this is an error. And it's in red, and red means error, right? So if I try to say light turn on, then that's an error because light is a class and not an object. Okay, so at this point, understand the difference between a class and an object. Are there any questions about that? This is a very important concept. Okay, what shall I? Actually, okay, so what I'm gonna, this way. All right, what I want to do is I want to demonstrate that.
So we know that since dot notation is only to access objects, and that's how we know it's not a class. Like just when we're looking through code.
No, it's not a class. There are ways of using the name of a class and sending a method. There are ways of sending a message to a class that we'll talk about later. So kind of hold that thought, but it's not using a dot or not. It's the fact that the light class cannot receive a message called turn on.
So you can use the methods to do that. That you're not able to use a method on the class, or I guess
no, that statement isn't quite correct either.
Sir, quick question.
There are messages that you can send to objects. Now, hear this and kind of put it aside. There are messages you can send to classes as well, but they're different. They have to be defined differently. And the thing is that I can only, what this says is I can send the turn on message to an object of type light, but I can't send it to the class light. So what's wrong here is not the dot, but the fact that the light class does not have a message called turn on. Only objects of type light have a message called turn on. Okay, does that, and again, we'll talk, the classes can receive messages called class methods, but that, you know, that's just going to muddy the waters here. So for right now, just think only objects receive messages for now. Okay, so I mean, I don't want to lie to you and say the classes cannot receive a message, but for now, just think only objects can receive a message, not classes. Okay. All right, let me find, where did you go? Okay, so what I'm going to show you here, let's see, is, oh drat. I think I have to share the whole screen for this. Oops. Are you seeing my whole screen here? Okay. Just to see what I'm doing up here, because, all right, so here, what I'm going to show you is how you can clone my repository. Okay, so now if you go to team, git clone, now, and then it says select a repository location. Now here, what you put in, what you can put in is simply the identical URL as you had, except have my username here, which is abus, A-B-U-S-S. And you should be able to just sort of type that in. Since you are a reporter on this, you can enter, again, your username and your NPS password. And what you probably should do is put it in since it has kind of the same name as yours, you should probably put it in a different location, because you don't want to override yours. Okay, so
you said you went to team and then get clone.
yes. And then when you say next, it'll say select remote branches, and there's only one, it says master. And then, so now here, well, here what you can do, and I'll do this here. Change the clone name to class code. So class code is going to be the name of my repository. And that'll help distinguish it from yours, because you don't want to mix the two. Okay, and again, this is being, okay, it exists, it's not empty. Naturally, since I was doing this before. Okay, I'm just going to delete that now. Okay, now, and if you do that, at some point, it should say, was cloned, do you want to open the project? Okay, we open the project. And as you can see, I've renamed my NetBeans project class code. And so far, all there is my hello world. So just to confirm that this is actually working. Okay, so there's the hello world. All right, so what I want to do now is I want to, I want to implement this light. Okay, so how do I do that? I go back to NetBeans, and here I will create another new class. So you've already created the Hello World class, so I do exactly the same thing. I create a new Java class. I'm going to call it light because why? Because that's what it was called. Okay, so I'm exactly matching the UML here. Okay, so now I have a public class light, and the only difference, because I chose a Java class and not a Java main class, it didn't write this main thing here. So what I'm gonna do is I'm gonna have another main class for this. Okay, so now again, I go directly from the UML diagram, and first it said there was a Boolean called on. Okay, so now here's the important thing. Notice I said private Boolean on. So why all that typing? Well, what does Boolean say? Boolean is directly from the UML specification. It said on was to be a variable of type Boolean, and this is how I declare this to be a variable of type Boolean. Now, what's this private about? What private means is that the only object that can change that variable is going to be this light. In other words, nobody else can even see or touch this variable. That's what encapsulation or data hiding is all about. And likewise, there was an int called level. And I define that again. So these are called instance variables. And every instance variable must be declared to be private. Again, I'll be talking more about this, but this is one of the key things that make object-oriented programming useful in large programs, because it means that the only thing that can change these values are things that I tell it in this class right here. No other code is going to be able to do that except through messages that I specify. Now, you're familiar with the concept of a constructor. I know that JavaScript has that concept. So here's how we define a constructor. It will a constructor does not specify a return type. Again, in later classes, I'll kind of get into more about this. But again, a constructor can be public or private. You want to make it public because if you don't make it public, then nobody else is going to be able to even instantiate this. So you'd better make it public. Okay, so now what does a constructor do? A constructor should always initialize its state variables. So when I instantiate my light, well, here I'll say that on is going to be false and my level is going to be, say, 0. Oops, equal 0. Okay, so now I've constructed it. And actually at this point, I can actually instantiate this light. And here's how I'm going to do it, though. I'm going to put it in another package. So I'm going to create a package, subpackage. I'm going to call it run. We'll be using things like this. And now I want to, at this point, I can actually instantiate this. And so let's do it just to, I'll call it test light. And again, okay, so in order to instantiate something, I need to specify what type of thing it is. Now, it's complaining. Now, if this is what's called, what's my past students have called this the red squiggly of death. Okay, so but what's nice about NetBeans is they have these little hints. So if we kind of click on the hint, we see that we have a number of different options. Its problem, see if we hover on it, it says it can't find the symbol. Okay, so in order to do that, there are a couple ways. One is actually the most, if we right click and say fix imports, then what it does is it imports it. So that we'll talk more about this import statement, but because we're in a different package, we have to import the class. Okay, so I've declared my light to be a light. And now I've instantiated it. Okay, so we can see what we have. Okay, so yeah, see Java, NetBeans has gotten kind of a little smart on us. I can't even instantiate, I can't even print it because it says, notice what it says, might not have been initialized. Why? Because at this point it is null. Can't do. But here I can actually do it and I can run the file. It's not going to do anything. But I can print it. Every object can be printed. And what does it print? It prints, well, it prints the name of the class and some gobbledygook. Not very useful. Okay, we'll see about fixing that. The way to fix that actually is through a method called toString. And now, again, since you all dealt with strings before, and so you know that if I take strings and do a plus, then I kind of concatenate them. When I have this special method called toString, now when I run it, it now prints what the level was. Okay, so it says it was false and the level is 0. Okay, so this is my recommended way of implementing a class. First, you start with the design of the class. And the design of the class is this. So I begin by writing the instance variables. I declare the class, write the instance variables, and I immediately start testing it to make sure that it's working. So let's do one method, turn on. What is turn on supposed to do? Well, conceptually, it's supposed to turn the light on. What does that mean here? Turn on. A method and class names have to all not have any spaces in it. Okay, so turn on is supposed to do nothing but set it true. Now I can send the message turn on to light. In fact, I will do it here. I'll send a message. And here's where NetBeans is kind of very cool. Notice NetBeans gives me the options. Let me do that again. NetBeans actually gives me the option of simply selecting. That's very important for somebody like myself who tends to fat finger almost everything he does. And so what I'm doing is I'm simply testing to see if that method was implemented correctly. And so now if I run it, I see that on is now true. Okay, so the method worked. What the takeaway from this is that when you are writing a class, start by writing your, defining the class, writing your instance variables, writing your constructor, and then writing the methods one at a time. It's often useful to also write this toString thing so you can check on your progress. The one thing that, and it just, I keep saying this, and sadly, if you don't, every time either myself or someone else doesn't follow this step-by-step thing, what you wind up with is a pile of code that doesn't work, and you don't know where to start. Here, if something goes wrong, then I know exactly where to start. So let me see what was another one of these. Oops, what was another one of these methods? Brighten. I'm going to look at Brighten. Okay. Okay. So what's Brighten going to do? Brighten is supposed to increase the level by, let's say, by 1, increment the level. All right. But okay, here I've actually kind of made a mistake because I actually forgot to do anything. So, but when I go to test it, okay, I can invoke the method. All right. Okay, what am I looking for? Here the level is 0. Here the level is supposed to be 1. Okay, I run it. And what happened? It didn't go up. What went wrong? Now, if instead I had written all of the methods and then started testing it, and it started breaking or not doing what I expected, I wouldn't know where to start. But here I know where to start because it's something I just did. I was implementing this and I expected this to be 1 and it's not. What went wrong? Well, I can go back and I say, what did I just do? Well, I did this. Duh, I didn't do it. Okay, are you familiar with this construct, the plus equal? Okay, so Brighten just says increment it by 1. And so now when I run it, okay, success. Okay, and now I can do this for everything. Now there was one called dim. Okay, now dim will just decrease the level by 1. So if I say dim, I'm going to cheat here and okay, that looks like it's okay. So now it went back to 0. And what if I try to dim it again? I dim it again and I get a level of -1. Okay, so that's kind of a, when you're designing stuff like this, does a level of -1 sort of make sense? I mean, if it does, then no problem. But the way I'm thinking of it is that if the level 0 means that it's all the way dimmed. Okay, maybe on, but if the level 0 is just all the way off, a level of -1 doesn't make any sense. And so the dim method, now I need to kind of do something like this. So how about this? If level is bigger than 0, then I'll do that. Otherwise I'll do nothing. Okay. You all know what an if statement is. And now when I run it and I dim it again, I dim it twice, and now it's back to 0. So in other words, it's working. Okay, now here's the other, okay, so we had turn on, brighten, dim. These last two methods here, is on and get level, those are things called getter methods. And one of the nice things about, you say, well, how can I see whether the thing is on or not? And the answer is, well, I mean, here conceptually, here's kind of what it's about. Let's say, look at on. If a light bulb is on, you can tell a light bulb is on by looking at it. And if it's on, it's on. Whether it's on or not has to do with the electricity going through the filament or the gas or the LED or whatever type of light it is. Actually, you know, think of an old-fashioned bulb like with a filament. In other words, this on is like the filament. And if I want to turn a light on, I don't do anything with the filament. I do something with a switch. But if I want to see whether it's on, I can just kind of look at it. So these are things called getter methods. And what NetBeans lets you do is, if I right click and I click on something called refactor, encapsulate fields, this will, okay, now for this, I do not want setters because they're not part of the design, but I can create a getter automatically for everything. I want to make it the last method so it doesn't get in the way of things. And if I just, okay, with a couple of clicks, I've now created the is on and get level methods. And they do the right thing. Is on just returns on. It's going to, if on is true, it'll return true. If it's false, it'll return false. Get level simply returns the level. The last thing is, what was the last one? Oh, turn off. Wax on, wax off. Okay, so let's test that. Turn off. Okay, so what am I looking for? I'm looking for on now being false at the very last one. And there it is. Okay, so what I've done is I have implemented this class. And while I've been implementing, I've been testing it as I go. Now, the one last thing to do, which I don't have time for here, is to comment it. But what I do have time for, hopefully, is to, now everything is working the way I want it. And now notice light and test light are now in green, which means they have been added. In fact, if I look at Git, show changes, I see that light and test light have been added. I can commit them. Here I can just click on this. And okay, just a brief comment, not like code comments, but you know, just enough. And then I say commit. And now now they're black, which means that everything is all up to date. The last thing is I need to push it. Now, there was a question before about, okay, come on. Okay, so here's my CS project, and you'll notice that I still only have hello world there. All right, that is because I need to push it, and I will do that now. So again, I right click, I choose Git, remote, push. Again, make sure that I'm pushing to the right thing. Now, if you try to push to my repository, then it won't work. But in this case, I just have that one. You should, if you pull mine, you'll have two. Okay, now here, the local branch was updated. I'm going to update the remote branch. I finish, it's pushing, and now if I refresh, I see here's my light. And then here's my test light. And again, this has not been commented, and it should be, and it will be. Okay. So, okay, so that's it for today. And if there are any questions, post them in either in the discussion forum or send me an email or something. But now, if you have cloned my repository, you can now just do a pull. If you haven't cloned it, you can clone it and see everything that I've done. And then you can also watch the video to kind of follow along. Okay. And without further ado, we're not going to do anymore. So we'll see you tomorrow.
Sir, the video is posted in on Sakai, right? This recording of this class?
Yes. Well, it's actually posted on a YouTube channel, but there'll be a link to it in the lessons.
Okay, make sure.
Okay.